have recorded all that, but I didn't.
Is there an arithmetic infinite
No, we don't have a formula for that. Okay. You ready to go? Here's what your test is going to be. It's these concepts. If you can do these concepts, you can do what you're going to see on the test. They may be worded a little different or rearranged a little bit, but the ideas are here. So this is a good practice for you. Number 1 says, given the sequence, 2, 6, 10, 14, ... 118. First of all, is this infinite or finite? It's finite. It has an end to it, right? If it's ... with nothing behind it, it's infinite. But that doesn't mean you can't use a finite formula if you're finding a set number, like the sum of 15. This is not a sum formula. So given this sequence, we're going to write a recursive formula and an explicit formula. So the first thing you have to figure out is it arithmetic or is it geometric? Okay. What is happening here? You're adding 4 each time. Okay, so if we're adding 4 each time, sorry, I can't unplug. My kids apparently used my iPad and it was dead this morning. So whenever I'm plugged in, it does weird lines like that. This is my apology to you. You're going to get weird lines. So we're adding 4 each time. Okay, that means we're in this realm, right? We're dealing with the arithmetic because we're adding. So the recursive formula is going to be a sub 1 equals what? 2, your first term. And then a sub n, remember with these recursives, it's always a sub n equals a sub n minus 1, right? This part is not going to change. And then behind it is plus d. So we're just going plus 4. So that's your recursive. Then we write an explicit. So now we're using this formula, okay? A sub n equals what? 2. A sub 1, right? We're going here. A sub 1 plus n minus 1. And then what's d? 4 times the 4, okay? And like I said, if you put the d out in front of the n minus 1, that's totally fine. It's commutative. You can put it on either side. So then simplify that. We'll distribute that 4. So 2 plus 4n minus 4. So a sub n equals 4n minus 2. Okay, that's your explicit formula. So how do you find a sub 15? Plug it into which one? The explicit. Whenever you're finding a like high number, term number, plug it into the explicit. So it's going to be a sub 15 is 4 times 15 minus 2. So 4 times 15 minus 2 is 60 minus 2 or 58. So a of 15 is 58. Okay, your 15th term is 58. Then it asks you for the sum. Which formula are you using for that? First, second, or third?
First.
The first. It's arithmetic, right? We're adding. So you're going to use that first formula. So it's going to be the sum. Do you know what n is right now? We don't know what n is, but we can find it pretty quickly. How do we find it? Do you have the explicit formula? You do, right? That's this right here. Do you know either one of these things, a sub n or n? What is a sub n?
118.
It's 118. It's always your last term, right? So we know our last term. It's 118. So if I just plug that in, 118 equals 4n minus 2, then I find my number of terms. So I'm going to add 2. So 120 equals 4n, divide by 4. So n is 30. Okay, so don't forget you have the explicit formula there. If you don't have the explicit formula, you need the explicit formula, okay? Find the explicit formula, and that will help you solve for n. So S sub 30, right, the sum of those 30 terms is your number of terms, n, over 2, and then times your first term plus your last term, right? A sub 1 plus a sub n. So we're just plugging into this formula right now, okay? S sub 30 equals 30 divided by 2. What's a sub 1? 2. What's a sub n? 118. Okay, plug that into your calculator. She's not here. So I don't know if you want to just get that. I don't know how. Hi, though. Good morning. So what is the sum of those 30 terms?
1,800.
1,800. Yep. 1,800. So you're just plugging it into your calculator. This exactly how you see it. Plug it in. Okay? Questions on that? Yeah.
For part B, did you say we're gonna need to put it in like the an equals 4n minus 2? Like we're gonna have to,
Versus leaving it like this.
yeah, pull that wrong.
I don't know. I want you to put it in the simplified form. But at the same time, I don't know that I care enough to take points off if you don't. So I'll probably just let you leave it. The trouble with letting you leave it is when you get to summation notation, I don't want you to leave it. I want the simplest version in summation notation. So if you can remember to do that in summation notation with the funky, you know, S, which looks like an E, then yeah, I won't mark off for it, I don't think. Okay, next one. Here's your sequence. Tell me, is this arithmetic or geometric? How do you know? You're multiplying, right? You're going times 3, times 3, times 3. That should always be your first question, you guys. Is this arithmetic or geometric? Because that's going to really narrow down what you're working with, okay? So a recursive formula here, that means you're going from this stuff, okay? So the recursive is going to be a sub 1 equals 2, and then a sub n equals a sub n minus 1 times 3. Okay, that's your recursive. The explicit, now we're working with this formula, a sub n equals a sub 1. Okay, a sub 1 is your first term, the 2, times your 3 to the n minus 1 power. How do you find the 8th term? You're going to plug 8 into what? N of the first A or B? The explicit, right? This is going to go here. So a sub 8 is 2 times 3 to the 8 minus 1 power. So it's 2 times 3 to the 7th power. Plug it into your calculator. You should get a sub 8 is 4,374. Okay, now take a look at the sequence as it started. 2, 6, 18, 54, dot, dot, dot. Is that infinite or finite? That is infinite, okay? But now look at what they're asking you for. Letter D is asking for S sub 8. Which formula are you going to use for that? You're going to use finite because they're asking for the sum of the first 8. So we're going to have an end to it because we only want the first 8. Yes, the sequence goes on forever. We're finding the sum of the first 8. So when you do that, you're going to use this formula. Okay, that's going to go here because they're not asking for the sum to infinity. They're asking for the sum of the first 8. Okay, so what you're going to do with that is just plug into that. S sub 8 equals a sub 1, that was 2, times 1 minus, what's R? the 3, right? We were multiplying by 3. To what power? 8, your number of terms, okay? This is your n here. This is n right here. Put parentheses around that. And then we divide by parentheses 1 minus r again, 1 minus 3, okay? And I would plug that into your calculator right now just to double check that you're plugging it in correctly. Because if you're not, you're gonna wanna fix that right now. The good news is if you show me this and you get the wrong answer, I don't take a lot off because you knew how to do it. You just missed that last step of plugging it in, okay? So show me your work. Show me lots and lots of work. Right, so this one, because we're not doing the sum to infinity, we're only doing the sum of 8 terms, then we use the finite formula. If we were doing the sum to infinity because it actually goes to infinity, then we would use the other formula. Yeah. Okay, sorry, what'd you get? 6,560? Hopefully. If you're not, talk to me. I can help you fix it. Okay, number 3. These are really simple. Don't make these hard, okay? It says write the first 4 terms of the arithmetic sequence where a sub 1 is -5. So what's the first term? -5, okay? So you have one of the 4 answers already. D is 7, so what are you doing? Adding. You're adding 7 each time. So -5 plus 7, right, is all you're doing. So you get 2. 2 plus 7, you get 9. 9 plus 7, you get 16. Those are your 4 terms. Don't make it any fancier than that. Don't try to write a formula. Just plug it in. First 4 terms of the geometric sequence. So a sub 1 is 20. What are you doing to get your next term? You are multiplying by -2. So 20 and then -40. -40 times -2 is positive 80. And then 80 times -2 is -160. Okay. All right, arithmetic mean versus geometric mean. What's the difference? What do you do for an arithmetic mean? Add and divide, right? So you're going to go 31 plus 55 and divide by what? 2, because you have 2 numbers there. So that would be 43. Okay. Geometric mean, what do you do for that? You square root their product, right? 30 times 120 and square root it. So you get 60. So far, so good? Tell me if I go too fast here. Number 7, you write the first 4 terms of the sequence. So this first one is explicit or recursive? This is an explicit formula. With an explicit formula, I mean, always, you plug in n. It's just how n works is a little bit different. So if I want the first term, a sub 1, it's going to be 1 plus 2 times 1 minus 3. Remember, this is the one where I said just plug it into your calculator exactly how you see it, and then second enter will give you all that stuff back, and you just replace with the next number. So a sub 1 here, when you plug that in, you get -6. Okay, now go second enter on your calculator, and you should see that same thing back. Go to all the 1s and replace them with 2s. So now it's going to be 2 plus 2 times 2 minus 3. And again, you could do that in your head too. So if you want to do it in your head, do it in your head. That's fine. But you should get -4 for that. Okay, now do the same thing with 3s. And I don't need to see all of this from you, but I'm going to write it down for anyone who wants to see it all. So if you plug in the 3, I wrote that backwards. Hold, please. Yep, I wrote it backwards. thought it backwards. 3 minus 3 is 0. So plug that in and you get 0 because you're multiplying by 0. And then the fourth term is going to be 4 plus 2 times 4 minus 3. And when you plug that in, you get 6. Okay, so your first 4 terms of the sequence are those 4 numbers. Okay, letter B is where a lot of you had trouble on the quiz. So if you've zoned out, come back, okay? What is your first term? -4, okay? So there's a freebie for you. Your second term, A sub, it's -4, sorry, I missed the negative. Your second term is 3 times A sub 2 minus 1. And I feel like people get really confused with what A sub 2 minus 1 is. What's 2 minus 1? 1. So this is A sub 1. What is A sub 1? -4. Don't even mess with it. Just plug this number in, right? The number before it gets plugged in for A sub n minus 1 every single time. So 3 times -4 plus 2, right, is your A sub 2. When you plug that in, you get a -10. That's your second term. Your third term is 3 times the term before it, -10 plus 2. Plug that in, you get a -28. And then your fourth term is 3 times what? -28, the term before it, plus 2. You get a -82. Okay, so your 4 terms are -4, -10, -28, -82. Good? Don't let that sub n minus 1 freak you out. I feel like people just let it throw them for a bit of a loop. Okay, now I have a feeling, oh no, it is fixed there, kind of. So here's all the formulas again. The infinity just went away completely on that one. That's okay, we'll write it in. Number 8 here, it says find the sum of the series. First thing you got to figure out is what kind of series. So it's a sum, right? We know we're using one of these 3. Arithmetic or geometric? Arithmetic. Why? You're adding 3. Plus 3, plus 3, plus 3. Okay, so it's arithmetic. So which of those 3 formulas are you using? The first one, right? This one's the arithmetic. So we're going to say the sum of some number of terms. Do we know the number of terms right now? How do you find the number of terms? The explicit formula. So it's going to be A sub n. If you want to, right off the bat, we can plug in A sub n. What is A sub n? 64. So if you want to just plug it all in one shot, you totally can. 64 equals, so we're doing this, right? What's A sub 1? 4 plus n minus 1. N is what we're solving for, so you're not going to plug anything in there. Times what?
3.
Times 3. Times your common difference, this 3. Okay, now simplify that. You're just solving for n now. So if we go 64 equals 4 plus 3n minus 3. So 64 equals 3n plus 1, right? 4 minus 3. Take away the 1. So 63 equals 3n, and then divide by 3. N would be 21. Okay, so 21 is our number of terms. Now plug it into that sum formula. The sum of 21 terms is going to be 21 divided by 2 times what plus what? 4 plus 64. First term plus last term. So the sum of 21 terms here is, What do you get?
Sum.
714. Okay, so when it's a sum of an arithmetic, start with the formula, find your n, and then you can plug the n in with your a sub 1 and your a sub n. I used this one to find n, and then I used this one to find the sum. But I needed to know n before I could use this formula, right? So ultimately we're trying to use this formula, but we don't know n yet. So to find n, we have to use the explicit formula, which is that left one. They're all labeled on the first page, right? It's exactly the same setup as that first page of it. Yeah, okay? Okay, it says, if a of 1 is 5, d is 3, and n is 12, find the sum. What's missing? The last term. We don't know the last term yet, okay? But we can find the last term with what? The explicit formula. So the explicit formula is a sub n equals a sub 1 plus n minus 1 times d, right? I know a sub 1, d, and n. So if I plug that in, a sub n is what I'm looking for. I'm just going to plug in all those values. So a sub 1 is 5 plus n is 12 minus 1, d is 3. Okay, that you can plug into your calculator exactly how you see it. 5 plus 12 minus 1, or 11 times 3, means a sub n is, that comes out to 38. Yeah. Okay. A sub n represents what again? The last term. Okay, so we need that to find the sum. Is this arithmetic or geometric? You should know based on what we just did. Arithmetic, right? We had a common difference. So that means we want the arithmetic sum formula. So it's going to be the sum of what? What is n? Not 38. 12 equals, so 12 divided by 2, right? I'm just plugging into this formula right now. 12 divided by 2 times the first term plus the last term. Okay, if you plug that in, the sum of those 12 terms is 258. Do you need to stand up and stretch real fast? Get your blood pumping again? It's Monday morning, huh? If you need to, move around. Number 10 here. Given this setup, okay, and I'm telling you it is arithmetic, tell me the number of terms, the first term, the last term, and the sum.
On the test, you're going to tell us if it's right.
On one like this, I would, yeah. What's the number of terms? It is 40, right? If we're starting at 1 and we're going to 40, remember it's always the number is subtracted and you always add 1 to it. So 40 minus 1 is 39 plus 1 is 40. So there are 40 terms. If this is 1, this is always n. Okay, if that bottom number is 1, your n has to be whatever's on top. Only if it's 1. If it's not, then you need to make sure you do this. Subtract and add 1. How do you find your first term? Plug that one in right here, right? 5 times 1 minus 1 is 4. So our first term is 4. What's the last term? How do you find the last term? Plug in the 40, yeah. So this is going to be 5 times 40 minus 1, which is 199. Okay. So then the sum becomes really easy because you just found all the parts. You found your n, you found your a sub 1, and you found your a sub n, right? So plug that into your sum formula. The sum of those 40 terms is going to be 40 divided by 2 times the first term plus the last term. Okay, so your sum is 4,060. Yeah, Jada. The sum of the arithmetic, the one that's circled up here. Because remember, it's arithmetic, and we're finding a sum. So use the sum of an arithmetic formula. Okay, number 11 says write the first 3 terms of the infinite geometric series if r is 0.2 and a sub 1 is 20. Which formula do you have to use for the sum? Here's your 3 sum formulas. Which one are we using? The last one, because we're doing the sum to infinity, right? Well, first of all, how do you find the next 2 terms? If we start at 20, how do you find the next term? Multiply by 0.2. So 20 times 0.2 gives you 4. And then do it again. 4 times 0.2 gives you 0.8. Okay? The sum is going to be plugging into this one. So a sub 1, God bless you, a sub 1 was 20 divided by 1 minus the 0.2, right? Your rate, common ratio, if you will. So you plug that in, and what do you get? 20 divided by 1 minus 0.2. You're gonna wanna check this. Make sure you're plugging it in right. What'd you get? $25, yes. If you're not getting 25, make sure you talk to me about it. Now, what if I said find the sum of S of 10? Then what would you do? Then you would use this formula instead, right? Because then it's not going to infinity. Then it's a finite number of terms, okay? We're not going to do that, but if that's what you had to do, make sure you use that formula. Okay, number 12 says find the sum. What do? Plug it into your calculator, right? Remember, math 0 or alpha window 2. Okay, but math 0 will give you that setup, and then you plug it in. Now here's the deal. It's going to start a parenthesis here for you, right? You don't want to put the parenthesis around it until you're at the very end. You want that entire equation inside of your parentheses, okay? So plug that in. You got a 6 on bottom, an 8 on top, and then negative 5 times 3 to the n power. What would your sum be? Should be a negative, and it's a fairly large number. What'd you get?
47,300.
Yeah, negative 47,385. Now, if you wanted to, you could use the sum formula if you like that better. You just got to make sure you realize this is geometric, right? So this is the sum of a finite geometric series and find all the pieces. I would just plug it into your calculator, quite honestly. All right, this one, letter B. What did I plug into what? I plugged all this into the calculator. So you hit math 0 or alpha window 2, and then just fill in all the gaps. x equals 6 on bottom, and then your formula behind it, 8 on top. Okay, letter B. Plug that into the formula. Make sure this whole thing is in your equation, parentheses. What do you get? $302. And again, if you want to, you can do 7 squared plus 2 plus 8 squared plus 2 plus 9 squared plus 2, plus 10 squared plus 2, right? You could do that, and you'll get the right answer. It's more work, but you can do it that way. So keep that in mind. Okay, 13. This says find the sum of the first 300 numbers. Now, if you think about this, the first 300 numbers, is that going to be an arithmetic or a geometric? Arithmetic, you're adding 1 each time, right? 1 plus 2 plus 3 plus 4 plus 5 is essentially what you're doing. The sum of the first 300 numbers until you get to, so what's your last term going to be? 300, okay? If you can't find that, a sub n equals a sub 1 plus n minus 1. The explicit formula will get you there. So your number of terms, anyone know it? Again, if you don't, you can plug it into the explicit formula. It'd be 300, right? This would be 300 terms from 1 to 300. So your number of terms is 300. What's your a sub 1? 1. What's your a sub n? 300. So if you take this and plug it into the sum formula, the sum of those 300 terms is going to be 300 divided by 2 times 1 plus 300. Okay? Plug that into the formula. So the sum of the first 300 terms is a fairly large number, 45,150. Okay. All right, number 14 says write the arithmetic series using summation notation for 15 terms given the first 3. So summation notation, right? That's this guy. We're going to say n equals what on bottom? Not 7. N equals 1. Whenever you guys are writing summation notation, it will always be n equals 1 because we want our first term, right? This is your term number, not the value of your first term. So n equals 1, okay? It says for 15 terms, where's that 15 going to go? On the top. Okay, and then we need to come up with the formula. So your explicit formula is going to go right here. So we're going to say a sub n equals a sub 1, 7, plus n minus 1 times what? How'd you get to the next term? 5 plus 5. Okay, so simplify that. You get 7 plus 5n minus 5, which would be 5n plus 2. So a sub n is 5n plus 2, so we'll put 5n plus 2 right there. And that is your summation notation. Last two. This one's a little bit of thought here because it's the word problem, right? It says a 60-row theater has one aisle. So basically what they're saying is there's seats here, an aisle, and seats here, okay? We don't know how many, but that's the idea. One aisle. Both sections have 20 chairs in the first row. So that means there's 20 here and there's 20 here, okay? And then each row after that has 2 more. So this one's going to have 22 and 22. This one's going to have 24 and 24, right? So each row is growing by 2, okay? So what they're asking you is the total seating capacity of the theater, which is a sum, right? Add up all the seats. So we're eventually going to get to a sum. Let's just start with a general setup, okay? Do you know n? Actually, before we get to n, what's the first term of your series? It's not 20. It's 40, right? The first row has 20 and 20. So 40 is your first number. What's your next number? 44. Yeah, 22 and 22 means the second row has 44. And then your next one has 48. Okay? We don't know what our last one is yet, but we're going to find it. How do we find the last term? How do you find a sub n? The explicit formula, okay? So you're going to say a sub n equals what? The first term, so that's 40, plus n minus 1 times what? 4, right? You added 4 each time. Oops. Well, whatever. Parentheses, no parentheses. That doesn't really matter there. So if we simplify this, we get, we're just going to simplify first. You could plug in n right now. Do you know n? It's 60. So if you want to just plug in 60 right now, you can plug in 60 before you simplify. That's fine. 60 minus 1 times 4 is going to get you your a sub n. Right? So if you plug that in, you get 276. Okay, so that's essentially what goes here, 276. So if I'm trying to find the total seating capacity, which formula am I using? The sum formula, okay, for an arithmetic, right? We're adding, so that's the guy we've used a whole lot already. So we're going to say the sum of 60 terms is 60 divided by 2 times what? 40, the first term, plus 276, the last term. All right, so plug that into your calculator. You get S of 60, the sum of those 60 rows is going to be 9,480 seats. Good on that? Last one. Okay. This one says the first term of a geometric series is 8. So 8 plus, and then whatever. If there are 20 terms, so what does 20 represent? N, your number of terms. And R is 2, what is the sum? Which formula are you using? The middle one, right? Because it's a set number of terms, but it's geometric because there's an R. So we're going to use that middle formula. We're going to say the sum of those 20 terms is going to be the first term times 1 minus your R, which they told us was 2, to the nth power, and n was 20. Okay, put parentheses around that. And then divide by 1 minus your rate, again, 1 minus 2. So you're going to plug that into your calculator. And the sum of those 20 terms is a very large number. $8,388,600. Whew! Look at that timing. You made it.